Today we talk about dividing polynomials, right? Polynomials, to divide them, first one, real simple. We will take some sort of polynomial and divide it by a monomial. What the heck's a monomial? One term, right? Do you see how up top we have a polynomial, many terms, right? Polynomial, and we are dividing it by one particular term. Sure, there's three things down there, but it's just a term, 3xy. Cool? We're going to do it baby step-wise because we really weren't that good at it last semester. We kind of gave up on life when we were trying to simplify this stuff. So what I want us to do is separate this. If there's three terms up top, we're going to rewrite this puppy as 6x to the fourth y cubed over 3xy. Right? I'm just going to take this denominator and put it over all three individual terms in the numerator. And then isn't the next guy plus 12x cubed y squared? That will be over 3xy. Then minus 18x squared y. That will be over 3xy. And I know that once we do a bunch of these, you'll be able to probably do it without rewriting it like this. Too bad, so sad. I'm going to make you rewrite it every single time. Okay? And now we just simplify each individual situation. So coefficients, 6 over 3. Can that simplify? 6 over 3 is 2. X's. Are there any negative exponents involved in this situation? Nope. Where are there more x's? Upstairs. How many more? X cubed. And same thing with the y's. Wouldn't there be a y squared left over? Correct? Over here, next guy, it would be positive. Coefficients turns into a 4. X's, more upstairs. Isn't there 2 more up there? Right? And y's, you would get 1 more y. Right? And finally, I'll let you do the last one. It's going to be minus, right? Because that's a minus. Just simplify that last one. 18 over 3 turns into a 6. X's, there's more upstairs. Y's cancel each other out. There's the same amount top and bottom. Pretty simple on that. Box it. That's our answer. We just divided a polynomial by a monomial. Let's do it again. Let's rewrite this puppy as individual terms on top of each other. And I'll tell you, even with all the experience that I have, it's easier after you do this. It's of course a pain in the butt to rewrite the whole thing, you know. I know you don't like it, but once you've done it, it makes doing this process a piece of cake. So every term in the numerator is just over that denominator. Groovy? Now let's simplify it. 20 over 4, coefficient-wise would become a 5, right? C's, more upstairs. D's, 1 more upstairs. F's, what happens to those F's? I agree that we can say that they cancel out, but just to kind of understand, it's really F divided by F, which turns out to be how much? It's 1, right? So we put a 1 here, and then you take 1 times 5. It's kind of like there's nothing there, but there's really a 1 there. You with me on that? All right. Next one, minus, and then there's a 4. When you do the coefficients, the C's cancel each other out to be 1. The D's cancel each other out to be 1. And don't you have 1 more F upstairs than you do downstairs? And that leads us into the last thing, right? If you use that concept of they cancel each other out, a lot of people would put nothing for the next thing. But don't the 4's cancel, the C's cancel, the D's, the F's cancel? What's really left right there? There's plus 1, because it all divides out to be 1. It's like 5 over 5, which is 1. You with me on that concept? And then we box it. Next. Ooh, doesn't look like a division problem at all. It does not look like a division problem, but do we see this particular guy right here? That's got a negative exponent, and doesn't that mean that that guy would really change houses to where, I'm not going to make you write this, but if you changed houses, wouldn't it look like that instead? Wouldn't it have to go downstairs? Right? That 3xy goes downstairs. Then instead of writing that, can you just go ahead and rewrite it where it's all separated out already? You'd take this brother of 18x squared y, and wouldn't you have to put it over the 3xy? Like whatever this particular dude to the negative 1 is the denominator, right? And then you'd have plus 27x cubed y squared z, please cross your z's, over 3xy. And get her all divided out for me. One more. You don't have to rewrite it as a division problem, like as one giant division problem, but I do want you to rewrite it as individual guys over the denominator. What's the denominator? AB. Because of that negative exponent right there, it changes house and goes downstairs. So now, before you get going, I want to change this problem to be some that are a little more like your homework. So I'll have you have it written like this. Is everyone good with like that? All right? Now, all of the ones we've done so far came out nice because there was always more upstairs than there were downstairs or something like that, etc., etc., etc. So let's do this. Let's just change it to a 3b squared just for fun. Like, instead of the denominator being that, let's just see what the heck would happen if it was something like that. All right with that? Just making up something just to be a little closer to ones on your homework. 3's, don't they cancel out to be 1? A's, there's more upstairs, right? And then B's, aren't there more downstairs? So wouldn't that have to turn into just A over B? You with me on that? Minus 6 over 3 is 2. A's, cancel. B's, where are there more? So it's over B, right? And then plus, oh my goodness, 5 over 3, does that simplify at all? So it's still 5/3. A's, cancel. B's, cancel. So things can get nasty, you know. It's like you can have fractions, you can have stuff downstairs, you can have stuff upstairs. It's the same old game we were playing before. Where are there more? Where are there more? Where are there more? That was very easy because what were we dividing by every time? What kind of polynomial is this? How many terms is there right there? Monomial. Dividing by a monomial, piece of cake. Cool? The division algorithm. Now we've got a polynomial right here. Yeah. And we want to divide it by another polynomial. Problem is, this is not a monomial. That's a binomial, correct? So the first way we will do it, you will think is probably all right after we do about 4 examples. Like, oh, that's all right. We're going to do long division. Going back to like 3rd or 4th grade, whenever you learn to do long division. But then after we do a few of these, I will show you the awesomest division trick in the world to how to take a polynomial divided by a binomial. But first, we got to crawl before we can walk. So here's how we'll set it up. We will say x minus 5 is what we're dividing by. And then we put this cool division symbol. You know, it's not a radical. It's a division symbol. And then x squared plus 3x minus 40 goes underneath there. Just like if you wanted to do like 42 divided by 5, you'd write it as 5, and then you put the 42 in there, and etc. You do long division, you know, stuff like that. That's what we're doing. We're going to take this divided by x minus 5. So far, so good on the setup. We don't really care about this minus 5 part at all. We really just care about this first guy right here. It must be a variable. It must be the variable. We'll see some tricky stuff coming up. But we want to take and see how many times does x go into x squared. If you took x squared and divided it by x, what would you get? Like if I wrote it like this for you, x squared divided by x, what would you get? X. That goes right here. Cool. X goes right there. Then we multiply. We want to take x times x, and what would you get? X squared. Now I want to show you something weird. X squared. Then we multiply x times negative 5, and we get what? negative 5x. We're just going to multiply those out. But the thing says you're supposed to subtract these from each other, right? So what ends up happening, just watch me for a second, is you have to subtract away this entire situation when you're doing the long division. And that's difficult for people to do. So what I like to do is realize that this is just like distributing a negative 1 through there. Doesn't that just kind of change all the signs in there? So what I realize is if I was to start over, I'm going to multiply. I'm going to do x times x. Isn't that x squared? Right? I'm going to change its sign right away. And wouldn't that be minus x squared? Then I'm going to take x times negative 5. Don't you get negative 5x? I'm going to change its sign right away, and I'm going to get plus 5x. And now I just add those together. Cool? I just add those together, and these go away. 3x plus 5x is how much? 8x. And then you just bring this minus 40 down. Awesome. It's just long division. Cool? So like to do it with a number example, if I wanted to take 3 divided by 107, don't you see how many times does 3 go into 10, right? It goes in there 3 times. You'd multiply those together and get a 9, and you'd subtract them from each other and get a 1 and a 7 right there, you know. But subtracting is pretty simple when there's only one thing happening every time. Subtracting is not that simple when you've got an x squared minus 5 in there. I want to change the signs and add them together instead. Is that all right with you? Then we do it again. We start over, and we see how many times, what's 8x divided by x? What would you get? What's 8x divided by x? 8, and it's a positive 8. And then we do the multiply opposite trick. We'll take 8 times x and get 8x, correct? Then we'll change his sign and do minus 8x. And then 8 times negative 5 is negative 40, but I want the opposite trick and put that right there. Sound all right? If I add those together, what do I get? 0. This is our remainder. That means that x minus 5 went into x squared plus 3x minus 40 evenly, right? It totally happened. Is that all cool with you? So we got a remainder of 0. It says, I don't even know if it says that. Well, what we want to do is recognize what's the quotient and what's the remainder. So we will label this quotient. The quotient is x plus 8. That's this thing right here. The quotient is x plus 8. And the remainder, that's this. Then we get 0 in that situation. So that's what we're doing. Long division. That was weird. Just one example. Like I said, after about 4 or 5 of them, you'd be like, dude, this is a piece of cake, right, to do this. Is that all right for one example? Let's try again. We want to take this trinomial divided by a binomial. You need long division to do that. So we'll take x minus 3 divided by that polynomial right there. What's this for? Just be patient throughout this chapter. It's like, why do we need to do this? Patience. You know, it'll make sense someday, but we just got to crawl before we can walk. Cool on the setup, right? First dude only. You take x squared divided by x. What would you get? You would get an x out of that situation. All good? Then multiply and do the opposite. X times x is x squared, but I want the opposite of that, so negative x squared. Groovy? X times negative 3 is negative 3x. I want the opposite of that because I'm supposed to subtract these from each other. Good deal? Then 7x and 3x is 10x. Correct? And then the minus 30 just comes down. Nice? Next, try it. See what you get. Work with PAL. Take 10x divided by x. Put it right here. What would you put right here? Plus 10. Then we multiply and do the opposite to bring her down. So then we'll take this plus 10 times x and get 10x, but I want the opposite of that and get a minus 10x. And then 10 times negative 3 is a negative 30. I want the opposite of that, and I'll get a positive 30. And I realize that my remainder is how much? 0. Okay? So then we got to write it out. Quotient. What's our quotient? X plus 10. And our remainder. This is how it's going to be on your homework too. Like, got to write this out. Quotient is this. Remainder is that. Thumbs up. Let's try again. Let's see what happens here. First move, x squared divided by x. That would be x again, right? Multiply and do the opposite. Check yourself with me as we go along. Should have got negative x squared and a negative 2x, right? Add them up. You know these will always cancel. That's the whole idea behind it, right? And then this is how much right here? Negative 8x. Come on, baby. Write for me. Then the minus 20 comes down. So far, so good? Then we do it again. Negative 8x divided by x. What would you get? Negative 8. And then multiply and do the opposite. That would be 8x. And then that's a negative 16. The opposite of that, though, is a plus 16. Correct? Uh-oh. A lot of people got scared there because you get a negative 4 right there. Correct? And when this, degree-wise, which we don't even understand what that is yet, is smaller than this, because this has degree 0 and that has degree 1, that means you're done. Right? You're out of x's. You can't even go in there. This is your remainder right here. You get a remainder of negative 4, meaning that x plus 2 does not divide into this perfectly nice and neat and even. You have a remainder. So our quotient is what again? What's our quotient? X minus 8. And our remainder is negative 4. Now, you probably won't ever really see it written like that, but we're going to write it like that. I want you to write the other answer, or you'll see it written like this all the time. The final answer is x minus 8. Isn't that the quotient part of it right there? And then whatever sign this is comes next, over minus 4 over x plus 2. Where the heck did this come from, this x plus 2? That's what we divided by, right? That's what we divided by. So just for a numerical example, if divided by, let's say, 28, right? Well, 9 doesn't go into 2. You got to move the next one. How many times does 9 go into 28? 3 times. Multiply that out, you get a 27. Don't you get a remainder of 1 in that situation? So is what the final answer is. Take your remainder that for what you were really doing. Sound cool with that? Awesome. So put a box around both of these. The quotient is this. The remainder is that. You'll see it written very often as the quotient remainder over this divisor right here. Okie dokie? Don't forget, ask questions if you have them. That's where we kind of faltered at the end of the semester. Next one, go for it. Pause the video, get that done. You and pal see what we can get done. I thought we'd be. So we should have got a remainder of 0 in that situation. Our quotient turned out to be x minus 12. Next one, multiple choice. But there's a real trick about this one. First of all, it doesn't look like a divide. It's because don't you have this negative x come downstairs. Is it a monomial or not, what we're dividing by? It's not. You know, it is a binomial. It could be a trinomial or something. It's just not a monomial, correct? It is not a monomial. The thing is, if we rewrote it, which you don't have to do, it would look like this. And we got to do long division to do this until we learn the next trick. But there's a real goofy part of it. if I was to set it up as long division the way it would be written, it would be like this. I want to do it like so. See if you can figure out what's really, really messed up about that. The variable doesn't come first when we have it in this order, right? It says 3 minus a. We've got to have the variable coming first. So we can just do the old symmetric property and make them switch places, but is it a minus 3? Is that the same thing? What has it got to be? It's negative a plus 3. Isn't that the same thing? So when we got to divide this out, we'll set it out with long division, and we need to pull the old switcheroo on it. So let's divide this. Yes, you do need to divide this out because all of these answers are very, very similar. You got to realize the variable must come first. It's negative. The 3 is positive, so we had to switch that puppy around. I'll let us do a little long division on that. Well, I'll start you out. What's a squared divided by a negative a? It's a negative a again, right? If you need to write it off to the side, you know, that's what you just did. You did a squared divided by a negative a, and you're like, okay, it's a negative, and there's more a's upstairs. Then you multiply these together, and you get a squared, but you want the opposite of that, so shouldn't it be a negative a squared? You multiply the next ones together and get a negative 3a, but you want an opposite of that, so you get a positive 3a. Then take 10a divided by a negative a. Would it be positive or negative when you take 10a divided by a negative a? Negative 10, right? And then multiply an opposite. That's negative 30. We should get a remainder of 19 in this situation. Signs are crazy on these just because there's opposite here, and you don't have to do the opposite here. It's a little tricky. Now all we got to do is look through those multiple choice answers and see which ones are good. I can tell you right away, no dice. Why are we eliminating B? It has no remainder with it whatsoever, right? That means it came out nice. All the rest of them looking pretty decent when it comes to the old remainders. It's got a 19 up top. It's got a 3 minus a on the bottom, which really, that's right. Isn't it really 3 minus a? We just switched it around. 3 minus a, negative a plus 3. That's the same thing. But the things that we got to realize is a can't happen. Why can't a happen? Because our quotient is negative a minus 10, correct? It's just down to these two. The question is it going to be plus or is it going to be minus? It's all about what your remainder was. Was it a positive 19 or was it a negative 19? It's a positive 19, so the choice is C, right? The choice is C. Next one, give it a shot. Realize if you got to switch some stuff around or not. Based off using the multiple choice, it's pretty obvious if you're going to get a remainder, it better have something to do with the 13. You know, it's like out of all the remainders, it's 13, 13, or negative 13, right? It's either positive 13 or negative 13 if you get one. Maybe, just maybe, you didn't get a remainder, but we did. So not going to happen. It can't be this one. Why can't it be this one? It's not a negative r. Can't be this one either. It's got to be this one. And because of the quotient is negative r minus 6. Sound okay? What do you think about long polynomial division? It's not bad, but it is a little tricky. I will agree with that. The thing is, though, what were we dividing by every time? I know it wasn't a monomial, but it was a binomial, correct? And what was the exponent on this puppy every single time? It was a 1, right? So pretty simple to do. Well, there was a brother that did a lot of long division by way of what we just did. And he figured out a shortcut. And to see the shortcut, I want to do one more problem of long division. Let's do this problem real quick as long division. But realize down here, I want you to save some space to do the problem again. But here's how much space your long division will take. It will take up like this much in red. And then this short little secret will take up just about 2 lines worth of stuff right there. Okay, so let's do long division first. Wouldn't we do x minus 4 divided by, I don't even know how to say that right. I don't do long division. 2x cubed minus 13x squared plus 26x minus 24. Cool? And this is new because we always had a second degree polynomial in there. Now we have a third degree polynomial. The degree is like what the biggest exponent you see is right here. This is the third degree polynomial right here. Same concept. What's 2x cubed divided by x? What would you get? 2x squared. Right? Is everyone cool with that? We multiply and do the opposite. That would be negative 8x squared, but we got to do the opposite of that and get a positive 8x squared. So far, so good? Then those go away. Negative 13 and a positive 8 is how much? Negative 5x squared, right? All this other stuff comes down. The plus 26 and the minus 24 comes down. Good with that? And then we do it all over again. Yay! That would be a negative 5x when we divide it. Correct? And then we multiply again. You know that's going to turn out to be 5x squared. This would be positive 20x, but you got to change the sign and get a negative 20x. And we add them up. That's 6x minus 24. Right? And we do it one more time. Whew. Plus 6. We get minus 6x. That's negative 24, but we change the sign and get a plus 24. And what's our remainder turn out to be? 0. That's really not that bad, you know. I mean, sometimes you get a remainder, sometimes you don't. It's not that bad, but that's a lot of work, man. It's like, look at, if that's third degree. What if you had a fifth degree or a seventh degree? You had to do that process like 7 times if it was a seventh degree polynomial. So here's synthetic division. What this was long division, all right? Synthetic division is really, really slick. Here's what we do. If we're dividing by x minus 4, we need to realize what value of x would make this out to be 0. Because that's what all of this division process is about, is we're trying to find the zeros of this polynomial, where it crosses the x-axis at. So if we're dividing by x minus 4, could you tell me what value of x makes x minus 4 turn out to be 0? If x was 4, it's the opposite of that, right? Because this is always going to be a 1 for us when we do this. It's if that's a minus 4, we want to divide by 4, synthetically divide by 4. Let me say that again. We want to synthetically divide by 4, and we'll do it like so. So where you got room, let's just pretend that I have a little spot here. If you're down here or whatever, we're synthetically dividing by 4. Cool? Now put this cool little bracket type thing. It needs 2 lines, right? You're going to write a line of information here, and then you're going to write a line of information below it. What goes in the first line? It's all of the coefficients of this polynomial that we're dividing by. All the variables are just going to disappear, and we're going to deal with only the coefficients. Do y'all see those coefficients? Right? I didn't need to put any pluses in between them or anything like that. The only thing you have to worry about is if they were negative or not. Now, before I go further, I want you to realize that you have to hold a placeholder value if there's some missing. Isn't this a third power right here? Then you have to go down the line. Do you see a second power guy? Yes or no. Do you see a first power guy? Yes or no. Do you see a 0th power guy is what that really is. That's a constant term right there. If there was one missing, we'd have to fill in that blank with a 0. We'll see some of those here in a little bit, right? But you have to realize if this is a third degree polynomial, then there should be 4 terms in there because you have to always add in that constant term, right, of 0. So there should be those 3 guys plus the 4th. Sound cool with that? Now watch how synthetic division works. It's just a little pattern you need to memorize. First term comes down. Bring that 2 just straight down and put it right there. You all good with that? Then you do a little multiply trick. You take this 4 times 2. What do you get? And it goes right here. Just draw yourself an arrow the first time or two. You multiply and put her right there. Awesome. Then you add them up. What's a negative 13 plus 8? Negative 5. Now I want to stop and start to notice something. Do you see? That's what we got when we did it before. See that negative 5? Isn't that right there where that came from? That negative 5. Awesome. Then we do a multiply trick again. 4 times negative 5 is how much? That goes right in here. Whatever you get, it just goes back in there. Negative 20. Cool? Then you add these together. What's 26 and a negative 20? Positive 6. Time out. Isn't that what this turned out to be right here? That positive 6 right there. Then you do another multiply trick. 4 times 6 is how much? 24. That goes right here. And you add them together, and what do you get? 0. Then you throw a box around it like that. Because what is that thing right there, that 0? What is that part of it? That's our remainder. Every time. It matters if it's a 0 or not a 0, we put a box around it, and we'll say this is our remainder right here. We'll put an R next to it. Remainder, 0. What happened, though, is we just knocked this down a complete degree. If you take a third-degree polynomial and divide it by a first-degree polynomial, it'll turn into a second-degree polynomial. This, it's now time to reassign our variables, right? This is really the x squared term. This is the x to the first power term. This is the constant term. And there's your remainder right there. And if you look at it, isn't that what this quotient turned out to be in the first place? So answer, quotient was what? What's our quotient? 2x squared minus 5x plus 6. Remainder was how much? 0. And although you just got comfortable with long division, we're going to say goodbye, long division. We don't want to do you anymore. So let's try it again. But now, no long division. Let's only do synthetic division. Sound cool? We're dividing by this binomial. Isn't it a first power guy, right? And isn't the coefficient of that guy 1, right? Those are all key ingredients for synthetic division to work. What value of x would make this 0, though? Negative 3. So it's just like a little opposite game. Okay? Then put our cool little synthetic division bar right there. What goes in here is all of the coefficients of the one we're dividing by. Cool. But you got to make sure that everyone's represented. Isn't the biggest degree a 3? You with me? All right, the biggest degree is a 3. So then you got to check, is there a 2, a 1, and a 0 power after that? Right? Is everything got a place? 3, 2, 1, 0, so I need no placeholders. So we put a 2, a 3, a negative 4, and a 15. Nothing but coefficients in there. Sound good with that? Every single time in synthetic division, first dude comes down. That's how it gets started. First dude comes straight down. Awesome. Then multiply. Negative 3 times 2 is how much? And put that right there. And add them together. What you got? What do you get? Negative 3. Next move, multiply. Negative 3 times negative 3 is 9. Put it right here. And then don't you add them together and get a 5, right? Negative 3 times 5 is negative 15. Add them up. This is our remainder spot right here, and we get a 0 in that situation. Please put that little box right there and always put an R, telling me that you know that that's the remainder. The other things that I'm going to put, if it helps you, you can do this next step to go back and tell me what the quotient is. This is all of the coefficients, quotient right here. We just need to assign the correct variables with it. Since it was a third power guy in the first place, and we divided it by a first power, doesn't it knock it down one level to where this is really the x squared term, this is the x to the first power term, and that's the constant term right there. So if it helps you to put these three things in there, you can put them. I do not require them. Your quotient, though, is I do require, what's our quotient going to be? 2x squared minus 3x plus 5, and then the remainder was what? 0. Nice? Yes. See if you can set the next one up for synthetic division. The main question is this coefficient 1 and exponent 1? Then you know you can do synthetic division. If not, you got to change it around, and that's for FST. But what are you putting here, a 2 or a negative 2? Putting a 2. Check to see if you need to fill in any holes, right? Isn't it a third degree? Does it go down second degree, first degree, 0th degree? Do you have a representative for each spot? We do. And then go ahead and do your synthetic division. The first move is put that arrow there. That guy comes down. I don't know if you had your eyes up on the screen. After I had it all set up and I put my 3 here, it took me about seconds to get the rest of that stuff done. Instead of doing the division, zigzag your way to happiness to find that. Whoever figured that out, I'd like to shake his because he saved math students hours and hours of time. Because I know it's weird, depending on what level you go to next, but all of this stuff we're doing this semester is really practice to get you ready for calculus. It's kind of where, that's what FST is also. It's practice to get you ready for the calculus stuff now. Next one, let's get her done. I know a lot of you will not take calculus, so that's kind of why people are like, I don't understand why we need this. Well, maybe you don't need it. Now, here's the question. Don't we put a negative 2 out here? Right? This is a 4th degree guy, right? So is everyone represented in this polynomial? There are no 3rd degree guys in here, right? So we got to start with a 4, and what do we put in place of the 3rd degree person? We got to put a 0 there. It's very similar to like when we were doing our matrices and writing that augmented matrix. If there wasn't a guy there, you got to say that there's 0 of them there. Everybody has to be represented. And an easy way to check, let me show you real quick before you get too far, is if this is a 4th degree dude, there better be 5 guys in there, right? Because there's got to be one more because of that constant term. There better be 1 plus this number in there for a representative. Awesome. Get her done. Four x what? Cubed. Because it was originally a 4th power, it just knocks it down 1, right? It's a 3rd power minus 8x squared plus 18x minus 40, and then the remainder is 92. You may, this is how I want it. That's it. That's all we got to put. You may see it written like this. If this part wasn't there, you'd say plus 92 over what? A plus 2. Like that's how a lot of times you'll see a remainder. It's like 92 over that, but we'll do it this way. Cool. Next one, if there is more. Yep, let's do her. Realize, do you need placeholders or not? So sometimes I put a little indicator in there that I need a placeholder at this spot. You know, it's like I need an x squared guy. You know, so whatever floats your boat there. And if that's a fourth degree, I better have 5 guys in there. Let's do the next one. How many guys should you have in there if that's a fifth degree polynomial? You should better be 6 of them in there. Make sure you use the right variables also. A lot of people use x's all the time.